Good evening. I have the pleasure to present our next speaker. Good evening and good morning. We are now going to have a presentation from Ketil Stoknes. He is a senior project leader at Lindum. Ketil is a PhD researcher. He has one foot in the commercial industry of waste treatment and another in academical research. Ketil is an applied biologist and expert within ecology and waste-related microbiology and food production. The last 11 years, he has led biogas and compost-related projects in Lindum. In 2020, he completed a PhD based on his work called Circular Food. We will not have any questions or session for questions after Ketil's presentation, so I would recommend you to post your questions in the Q&A, and Ketil, he will be able to answer your questions there. So the floor is yours, Ketil.
Yes, thank you very much for inviting me. It's a pleasure to be here. Today I'm going to show and tell you about food waste treatment in Norway, or at least part of Norway, where we have a plant which is called the Magic Factory. And I hope I'm able to make you understand why it's called the Magic Factory as we go through this presentation. So the Magic Factory is a biogas plant treating food waste and also animal manure. But first of all, Lindum, can you take next slide, please? Lindum is situated in the southeast of Norway with several departments around with landfills and treatment plants for various types of waste. Next, please. We are operating both within biological processes for organic waste and also different kinds of recycling and environmental technologies such as odor treatment and so on, and also we operate several landfills for typically polluted soil and masses containing heavy metals and organic pollutants and so on. Next, please. In most of Norway now, we have source separation of food waste, and there are basically two types. One is a system where we have several bags, a green bag for food waste and a blue bag for plastic waste, and other kinds of shopping bags for residual waste. And all these kinds of waste are put into the same bin and then brought to an optical sorting plant where food waste is separated, put into trucks that are transport this to different treatment plants. The other kind of system is using separate containers, and in these cases biodegradable bags are used. So either biodegradable plastic bags or paper bags. And I can say that it seems now that the lower system in this slide is the system that works best because it stimulates the highest percentage of source separation of food waste. And there is, of course, some technical challenges as well with the optical sorting system and bags that open and leak out the food waste and so on. So you can say that the lower alternative is the best. Next slide. We've also been discussing mechanical biological treatment of residual waste. And you can say that this has not been very successful because the bio waste which is extracted is not clean enough for using it in agriculture. So you can say that it has been considered by many areas and also many countries in the EU and so on, but has been mostly abandoned. And now the general policy is to go for source separation at the consumer level. Next, please. This is the bunker where we receive the food waste at the Magic Factory. And as you can see, there are still plastic, because these green bags that come from the optical sorting system, they are actually traditional plastic, non-degradable plastic. So, and other bags come into the same bunker, which are biodegradable. And even some objects present here, you can see that shouldn't be there. But all these things, they are sorted out in a mechanical treatment system. So if you take the next slide, please. So this is an overview of the Magic Factory. And you can see at the left, what we do here is that we actually put in the food waste, or we can say we put in a rotten tomato in one end, and we take out fresh tomatoes in the other end, because we have developed a cultivation system, a closed controlled environment cultivation system for vegetables, which I will explain a little bit in more detail. Yes, thank you. And the Magic Factory is taking in both food waste from 1.2 million people in Norway, and also animal manure, which contributes the liquid in the factory. And no water is used, so it's only liquid animal manure and food waste. Then this is pasteurized or sanitized, you can say, and digested into biogas. And the biogas is separated into CO2 and methane, or biomethane. And you can say that the carbon in the waste is leaving the plant as either methane or as CO2. And we are using the CO2 into the controlled environment agriculture. This is a pilot that you can see on the right side, a 1,000 square meter greenhouse pilot, where most of it is a test facility to demonstrate this kind of closed production. And the other part is a visitor teaching center where pupils, children and youth come in to learn about a circular economy. And in this greenhouse, in the process, we are also using the digestate, or the biofertilizer, we call it. Most of the volume is now used in open field agriculture for growing grains and feed for animals, but part of it is also used in the greenhouse. So we have plans for scaling up these greenhouses up to 10 hectares. And the system is based only on waste, in that we are using a compost as a growing medium from green waste or garden waste. So the effect is that this is a completely circular kind of approach to making use of all the elements in the food waste. Next slide. This is the digester residue, or the digestate as it's called, and it can be separated into a liquid and a solid part. What we are doing is only a kind of rough screening or filtration of this digestate, and that leads to a rather small part of solids. Unfortunately, the mechanical pre-treatment process is not perfect, so some pieces of plastic follow into the solid part. As you can see here in the picture, the green bags you can see the residues of it in the solid part. And we are currently developing a method to separate out these residues. At the same time, we are working upstream of the process to make all communities around use the biodegradable bags, so we can avoid having this plastic contamination in our product. Next slide. So I've been quite often making the point about the relevance of space research, because when we go to Mars, we have to make a completely closed circular system to sustain ourselves. And that research and that way of thinking is very relevant for how we should develop cities to grow food in a circular way. Next. This is the European Space Agency's loop developed for space. And as you can see, it's not only a matter of using the waste into a greenhouse to grow plants, but there are several other components necessary to degrade this waste and make the nutrients available for new food production. And of course, this is a very complicated microbial system, but it's very relevant for how closed systems can be developed. Next slide, please. There is a huge trend now towards plant factories or vertical growing systems in cities, as you can see one example of here. The trouble is with these plants is they're not really circular. They are based on mineral fertilizers and a lot of power use. So even though they are efficient in terms of nutrient use and water use and so on, they're not really developed for a circular way of thinking. And that is exactly what we have done at the Magic Factory, to develop another way of growing crops in a controlled environment based on waste. Next slide. So you can see here at the right part of this diagram, you have the degradation, the anaerobic degradation, and you also have several other organisms that are necessary to convert the waste. Next slide. And at the Magic Factory, we have actually exact the same components of the system and the same connections and arrows of how this works as in the space system. Next.
Okay,
this is show a video from the greenhouse.
Wow.
Showing that this is a completely different system from ordinary greenhouse growing, that we are using earthworks.
Yes.
So there is a kind of full ecological system. In the growing system consists of compost and worms that are you get less disease and a more efficient production system. If you want to use the digestate for growing crops, this is a way to do it that works. And from this pilot greenhouse, we are now selling these climate tomatoes or magic tomatoes from the Magic Factory, and they have been received very well in the market. People are asking for these tomatoes again and again because the quality is extremely high. They have a lot of taste and very good structure, and they are locally produced and picked at the mature stage. So yeah, they taste very nice. Next slide. We've also done a lot of research on growing mushrooms from the waste, and this is planned for also for scaling up. They're not magic mushrooms, but we could call them magic mushrooms from the Magic Factory. Next. So you can say that the waste pyramid also holds for organic waste. So in terms talking about waste reduction, that can be things like plan shopping and meals well and eat up your food. Next. or reuse of food waste at one level, at the household level, could be make beer from your dry bread and use leftovers in new dishes at home. Or you can even grow mushrooms on coffee grounds. Next, material recovery can be using digestate and compost for plant crops, like we do at the Magic Factory. And of course, biogas digestion or anaerobic digestion is a very efficient way of material recovery, not only energy recovery, but material recovery of food waste, because it's a closed process conserving all the nutrients, while composting is not as optimal as anaerobic digestion, because you lose a lot of the nutrients during the composting process. Next. And of course, incineration of food waste or landfilling is the absolutely worst thing you can do. Next, please. Yes. If you want to convert food waste materials most efficiently to new food, we can look at different fractions. So when you have food quality residues and byproducts, pre-consumer that is, they can be converted to new food through novel biotransforming technology, like, for example, extracting proteins from carcasses of chicken or things like that. While the waste is still food quality, it should be converted directly into new food. Next, mixed food waste, next please, is a broad biochemical substrate for heterotrophic food production. So for example, mushroom production or insect production are very appropriate methods to convert food waste. However, there is some challenge with the legislation, but I will come back to that next. And lignocellulosic materials, such as dry materials, they are carbon and energy rich sources for heterotrophic food production as well, or sustainable growth media for plants. Next, animal manure is an organic, can be used as an organic plant fertilizer or as microbial nutrients and wastewater treatment plant sludge, next, is the same thing. However, if you push double, if you take the next, please, and the next. The thing is that these wastes, they are to a varying degree appropriate for both biogas digestion and for using this way that I'm explaining, because in Europe at least, you cannot use mixed wastes directly for insect production, for example, because of the legislation. And you cannot use wastewater treatment plant sludge for growing vegetables in the field, for example, and so on. There's a lot of challenge around the legislation for doing this. So the optimal way biologically is not necessarily the possible way to do it. Next, please. We are also looking into more local cycles at the urban, in the urban environment, because this way of thinking, using food waste for biogas production and for vegetable production, can also be done locally. And we have calculated that you can produce a substantial amount of the vegetables needed for the inhabitants in this way, by combining greenhouses and other kinds of climate-controlled growing systems. And it can be both community level on volunteer basis or professional growing. Yes, thank you. That was the last slide.
Thank you, Ketil, for a very interesting presentation. As I said before, we will not be able to ask you questions, but please write the questions in the Q&A and Ketil will be able to answer it. We really need more of these magical factories, that's for sure. Thank you.
Yeah, thank you.
Okay, we will then move to the session of urban strategies for food waste. Good evening and good morning for the you who are coming in now. I will now, in this session, we are going to talk about urban strategies for food waste, and as we are going from value chains to value circles or loops, it requires that we have to rethink industry, products, business models, and consumption. We need to reset our mindset and change habits as officials, CEOs, employees, and consumer. And this has to happen fast if we are going to reach the climate goals. And waste is a key word in this context. And it's estimated that the waste within the food production is almost 1/3 of food produced. And food waste is a symptom of a food system that is not working. And in order to make a change, we need to approach the whole food system at once and include all the different stakeholders, industry, consumers, retailers, and the public, and authorities, not at least. And it's also important to have the action plan as place-based, because there is no one-size-fits-all, and there need different solutions to solve the waste challenge. But we need to cooperate and use technology, experience, and know-how to come up to speed. And it's not maybe much we can do, each and everyone, but together we can make a change. I will now present the panelists. We have four panelists here today, and I would like to start presenting Mr. Christopher Tan. He is a director of the Sustainability Divisions at National Environmental Agency in Singapore. Mr. Tan is responsible for strategies and programs to drive sustainable waste to resource management. In previous roles, he has worked on issues such as vector control operations, air quality policies, and applied research in the behavioral science, as well as environmental and resource economics. Christopher started his career as an economist at the Ministry of Trade and Industry, Singapore. And then we will hear from the speaker from Norway. That will be Mr. Ole S. Rød. He is a founder and CEO at Norsk Biogas. His education is within economy, marketing, and management. He has more than 30 years of experience in sales and marketing and management, both in Norway and internationally. He is an expert in has expertise in business modelation, strategy, and operationalization, experience from M&A processes, corporate and project financing. He has been instrumental in establishing new independent companies as a founder and co-founder since year 2000. Mr. Rød has and have had several board positions within industry, finance, IT, recycling, and renewables energy since 1990. After we heard from Mr. Rød, we will hear from a speaker from Singapore, which is Mrs. Kai-Ning Chua. She is a co-founder and CMO in Insectta Singapore. Kai-Ning is a passionate entrepreneur who believes that the smallest of creatures can make the biggest of impacts. As a co-founder of Insectta, Singapore's first BSF biotech company, she aspires to marry deep tech innovations together with nature to create technologies that extract valuable chitosan, melanin, and more from the BSF to increase the value of the growing insect farming industry. Last but not the least, we have Mr. Olav Hovlid, Sales and Marketing Manager at Fjell Technologies. Roy is a fish health biologist. He has 10 years experience in the pharmaceutical industry, specializing on aquaculture, vaccine, sea lice treatment, antibiotics. 7 years in commercial director, business unit manager of companies like Intervet Sharing Plug Animal Health and MSD Animal Health. Roy was innovation director of Reaper & Son Norway, which is a food manufacturing company, and he was founder and managing director of I'm missing something here. Yeah, of startup in 2019, and is currently the sales and marketing manager at Fjell Technology Group AS. I will now give the floor to Christopher, please.
Thank you, Sigridur. I'm glad to be on the panel today. Yeah, Sigridur mentioned I am from the National Environment Agency in Singapore, and the National Environment Agency's aim and mission is to have a clean, sustainable, and green environment for Singapore for current and future generations. I will speak a bit about our plans for waste that will form a backdrop for this, to try to talk about food waste. So in 2019, we developed the Zero Waste Master Plan. What did the Zero Waste Master Plan aim to do? It tried to move away from the linear economy of production, consumption, and disposable to take, make, and dispose to a new circular economy, which is on the next slide. So the Zero Waste Master Plan lays out Singapore's strategies for Zero Waste Nation with important roles for the government, business, and community in order to build a sustainable, resource-efficient, and climate-resilient nation. So on the left of this slide, we can see how a linear economy could turn into a circular economy. There are various loops that we can try to implement, such as to reduce buying, repair and reuse, recycling, and redistribution. And in general, the smaller the loop, the better. We also have targets under the Zero Waste Master Plan. In Singapore, we only have one landfill, one offshore landfill it's called Semakau Landfill off the southwest of Singapore. Currently, we project that it will run out of space in 2035. So we are doing our best. We must do our best to extend its lifespan beyond then. To do so, we are aiming to reduce the amount of waste sent to landfill per capita per day by 20% by 2026 and 30% by 2030. I mean, these are Singapore's plans that are in support of the Zero Waste Master Plan, as well as the Singapore Green Plan. The overall plan for sustainable development, which was released at early this year to chart out Singapore's sustainable development plans for the next 10 years till 2030. So how does Singapore plan to reduce the amount of waste sent to landfill per capita per day? The next slide, please. We are focusing on several key waste streams, particularly e-waste, packaging waste, including plastics, which was the topic of the previous panel, and food waste, which is the topic of this panel, and also a campaign and effort to get Singapore to recycle right, which means to reduce contamination. So we want Singaporeans to recycle more of these key waste streams as well as to recycle right. I will then talk a bit about food waste now. So we may have read that according to the estimates by the Food and Agricultural Organization, global food waste and food loss amounts to about 1.3 billion tons. So that's really a lot. In Singapore, in 2020, there were 665,000 tons of food waste generated in Singapore. This is about 1/10 of all food waste, and only 19% of that was recycled. The rest of it was disposed at the waste-to-energy plants in Singapore for incineration and energy recovery. So you see, we want to try to do our best to reduce food waste, raise the recycling rate. So reducing food waste, redistributing unsold or excess food, and recycling or treating food waste are key approaches in Singapore's food waste management strategy. And of course, the smallest loop and the best loop to close would be to redistribute unsold or excess food. And at the other end of the treatment spectrum, we have composters as well as anaerobic digestion, which can turn food waste into some useful outputs, such as compost, non-potable water, which could be used for cleaning purposes, or biogas from anaerobic digestion. So we also are trying to encourage more of something in between, food waste valorization. So food waste valorization could work at upcycling food waste into useful products, such as food to food, food to feed, or food to other products. And this is a new area that we are working on to try to encourage, together with other agencies such as the Singapore Food Agency and Enterprise Singapore. Recently there were Food Waste Valorization Awards, and some examples of food to food companies in Singapore which were given awards at that ceremony were Crust, a local beer brewing company that turns excess food from other companies, such as waste bread from grocers or bakers, and mixes them into the beer brewing process. So that's one food to food process. Another food to food process in Singapore is also this wow noodles, right? So there's this company, Cosmodi Health, which has looked at turning spent barley grains into low fiber, zero GI noodles that are also zero waste, because if we think about it, spent barley grains might otherwise be disposed of. Some other, and I'm sure that Kai-Ning will talk a bit more about black soldier fly technology. Kai-Ning's company was also a recipient of the recent Food Valorization Awards. Of course, these are some ways that we are working at to try to encourage better food waste management in Singapore. And we do hope that these will build together with our other zero waste strategies towards a zero waste nation. Thank you.
Thank you.
Okay. Thank you very much. Here's my slide. Good afternoon, ladies and gentlemen. Allow me to start with an additional backdrop of my affiliation with the recycling and waste to energy industry. My first encounter with the industry was back in 1995. At that time, I was employed by an expanding waste management company in Norway, Norsk. After years in the advertising and communication business, this was a brand new world to me. At that time, I found the industry rough and dirty and in many ways very immature. However, figures quite rapidly show that waste literally could be turned into gold. Already then, waste was an important driver in what later became the circular economy. Waste carries significant value and contributes to major value creation. I believe this was a consequence of the Brundtland Commission report over common future that was published in 1987. Already then, the consequences of an unsustainable society were seen. That's 34 years ago. In 2050, we aim to reach a zero emission society. It's only 28 years ahead. It tells me that we have no time to lose. As you well know, carbon dioxide is one of the 4 main greenhouse gases caused by basically power generation, transport and mobility, shipping and waste. The ongoing decarbonization supported by regulations and incentives turn more and more sectors into electrification, creating an expanding need for electricity. I guess the core of the green shift is transit to alternative power sources to fossil fuel. However, today we know that wind, solar, biomass, and hydropower cannot cover the power gap fast enough. It's a need for increased use of aggregated biomass. Food waste is premium biomass and a far more energy-rich addition to traditional agri-related biomass sources. However, utilization of the resource demand efficient technologies and system in use, as well as a well-compound value chain to be profitable. The core of this value chain is the pre-treatment, where transformation from waste into an energy-carrying commodity take place today and forward. I'm very sure that emerging technologies will open new doors for the utilization of biomass. We will see transformation into a broader variety of energy carriers through gasifiers, pyrolysis, and others, in addition to or in interaction with anaerobic digestion. Also here, pretreatment will play a decisive role due to the nature of food waste as a resource. In perspective, anaerobic digestion is most beneficial to the green shift. Technologies and systems are well known and tested. Upgraded to biomethane, the gas integrates with present needs, especially within the shipping and heavy transport sector, without major replacements of technologies in use. And not to forget, digestate from anaerobic digestion of food waste contains several vital nutrients. A further processing of these has the potential to become new inputs to several industries, resources that are as important as energy for our common future. So let me finish off. Food waste is gold in terms of the green shift. Food waste, in my opinion, will never go away. On the contrary, it will step up with increased living standards and an ever-increasing supply of goods. Thank you for your attention.
Thanks so much for the amazing introduction, Sigridur, and thanks for mentioning me, Christopher. I'm very excited to be here today on the panel. And my name is Kai. I'm one of the co-founders of Insectta. We are from Singapore. So many of you may have heard about the black soldier fly, but for those of you who have yet to meet this amazing insect, the black soldier fly is a growing superstar of the insect farming industry, known for its ability to consume food waste and valorize it into agriculture products such as insect meal and fertilizer. Now, today I'm going to keep my introduction short so we can go straight to the questions, because there's so much to unpack regarding the insect farming industry and what it can be. It's still a very new, very niche industry. And over here in Insectta, we are developing technologies to expand the black soldier fly's horizon beyond just agriculture. So what we do is we create proprietary processes to extract chitosan, melanin, and probiotics, and even more from this amazing insect. And we are serving the pharmaceutical, bioelectronic, and personal care industries. Now, the work that Insectta is doing has allowed us to imagine new scenarios that we've never seen before, such as the ability to harness insects against the fight against COVID-19, for example, or use them in biodegradable as well as biocompatible electronics. Now, in brief, how this works is that the black soldier fly, they consume food waste very fast, very aggressively. They grow very quickly as well, and then they are harvested for use. Now, traditionally, the larvae and the frass, which is the insect poo, are the materials that the industry takes out. But now with our technology, we can take out things like chitosan and melanin. Now, in brief, what these materials are, for example, chitosan, I have some examples over here. Okay, chitosan is a substance known for its antimicrobial and moisturizing properties, while melanin, which I have some examples over here, it's actually a natural pigment that what makes our hair black, as well as our skin tan. But far from being an ordinary pigment, melanin is also known to conduct electricity, diagnose and treat certain cancers, as well as serve as a bioscaffold in bone healing. So today, the questions I'll be happy to take are those related to insect-assisted waste valorization, the insect tech industry, social and economic attitudes towards insects, as well as how we can harness insects as the next sustainable source of high-value biomaterials. Thank you so much.
Yes, hello. I'm Olav from Fjell Technology Group. Give a small introduction to our company. We are involved in many fields that are relevant for the topic here today. We are a company with that grew out from the oil and gas industry that we still have some, as you can see from this slide, some activity towards, but it's not longer a priority. In 2012, we decided to have a sort of a green shift inside our own company and try to contribute to help the world become making a smaller footprint and become greener. So one of our primary business fields is wastewater treatment. So we are both involved in municipal wastewater. We have delivered municipal wastewater plants for both Mecca in Saudi Arabia and Monza in Italy, and we have an ongoing project now in Dordrecht in Holland, and we develop our own dryers and dewatering equipment for that purpose. It's a small picture, but one of our priorities now is also towards the fish and aquaculture industry, where we deliver complete solutions, and even what we call an eco-capture system, which is run without use of chemicals or polymers, where we treat the water from down to 0.1% dry matter or below and take it up to dry powder. And we are involved in a project in Singapore with this type of eco-capture system. We also have involvement in drying of biogas, which has been talked about earlier today. And as you can see from the other slide, we also have a strong involvement in CO2 capture. We have recently sold a company to Baker & Hughes, and we have another technology under development. So we are really trying to take part in the green shift. On the right side, you can see one of the other main focus of our company, which is mentioned here as protein recycling, which is very relevant for today's topic. With protein recycling, we take primarily fish waste, but also insects. We can also take the feces from insects and dry that up, but the primary focus is fish waste, fish cuttings, heads, bones, trimmings. We can even use blood and guts, and we make high valuable fish meal and oil, rich in omega-3 fatty acids in the oil. We have a strong presence in this market in Japan, but our primary market is of course Europe. And we have had several meetings with Innovation Norway and industry representatives and national government representatives in Singapore, discussing the potential for a national fish meal and oil plant, which I think there is a very good platform to build such a solution for food waste. You have a small country area and you're a very modern country. And as discussed in previous meetings initiated by Innovation Norway, we have also had a little glance at Tokyo, where the government has forbidden to throw away fish waste. So every day, 130 cars are driving out to restaurants, markets in Yukashima, Tokyo area, and collecting fish waste and bringing it to a central fish meal and oil plant, where they are making then food for production animals. So this is a very interesting potential for Singapore, even though it demands a lot of effort and collaborations. Our core competence is the drying technology. So we are involved in many areas not mentioned here, but we have a strong R&D backbone where we are investing in new possibilities, new technologies, new process optimizations. So as an ending, I can also say we are also involved with leading R&D environments in Norway to develop new high valuable products from fish sludge, which is the outcome from aquaculture. We hope there to make a high valuable fuel from the fish sludge. This is together with leading research environments in Norway. So we are involved in many of the topics here today, and look forward to discuss them later on, and thank you.
Thank you so much to each and every one of you. Very interesting. I will ask the participants if you want to raise questions to put them in the Q&A, and I will pick them up from there. Or if we are not able to answer them directly, that we will be able to answer them in written afterwards. Okay. I have the pleasure to ask you some questions, and I really would say that it's a very impressive plan you have for zero waste in Singapore, Christopher, and I assume that you are now in the process of implementing it. You are mentioned that also, Ole, that it is very important in the case of waste and utilization of waste. It has to be profitable solutions, and that means that we have to really be able to make valuable products and make a market for waste products or waste-based products. So I was just wondering, Christopher, if you can elaborate a little bit how you as a environmental agency and owner of this plan, how you can really make it easier, or the regulatory can make it easier to make these high valuable products and make the waste business like profitable.
Yeah, thanks, Sigridur. And yes, I do note Olav's point and about how there must be value in waste. And in fact, the business of turning waste through anaerobic digestion to biogas can be a valuable pathway. Yeah, it is a possible pathway and a valuable pathway, and NEA does recognize this. So in 2024 onwards, we are requiring commercial and industrial premises with large amounts of food waste to segregate their food waste for treatment. Some of these sorts of premises, just to give some examples, will be food manufacturing businesses, multi-users factories with more than 20 food tenants, hotels with food and beverage and function areas, shopping malls with food and beverage areas of more than 3,000 per meter squared. Yeah, so these are large generators of food waste. So we are requiring them to segregate and treat their food waste. So, so that is the first step towards working towards a circular economy for food waste, right? To get segregation done. And treatment, then I would say really has to be, there are several options that the companies can use for treatment. NEA is setting up this co-digestion facility at the upcoming Tuas Nexus facility in Singapore. So at Tuas Nexus, there will be, why is it called Nexus? It's because there are several sorts of circular flows of material going on there. There's a water treatment plant, which is part of Singapore's efforts to close the water loop. There's also a waste to energy plant, which will turn waste and recover it to generate energy, which will also help to power the water treatment plant, the water reclamation plant, as we call it in Singapore. And there will also be a food waste treatment facility, which will take sewage sludge from the sludge from the water reclamation plant and co-digest it with food waste. So that is one possible place that large food waste generators could send the food waste to. I mean, the other option, and I must also add that we do think that co-digestion of sewage sludge with food waste is a very valuable pathway. There's a pilot currently going on at Ulu Pandan Water Reclamation Plant, which has done well, and that is why we're implementing it at Tuas in Singapore. The large generators will also have options. They will be able to choose on-site food waste treatment, if that makes sense, such as composting. Just that we are requiring that any new shopping malls which start the building permission process in 2021 this year, they've already been required to do on-site food waste treatment. But all other facilities, especially the older facilities, will have the option of doing both on-site or off-site. Yeah.
Quite impressive. Ola?
Yeah, Christopher, let me add a few things to your comments there. I feel that this is, if you take Singapore and put the volumes you mentioned and put it into context here, I made some calculations and we maybe have a little bit differences in the volume that are generated, but I have figures from 21 that says that you generate approximately 740,000 tons of food waste in Singapore. Now you said 19% was turned into animal feed, or you didn't mention, but I got that from NEA. Anyway, it's a tremendous volume of food waste, and I don't think it's larger per capita than we experience in other countries, maybe less actually, but it's a tremendous volume. And just to give the audience a little bit what this is all about, if we turn it into something that are more closer to us, is I think it will be around 7.5 million liters of diesel equivalents if you turn it into energy, or 7.5 terawatt hours if you turn it into electricity. And also with AD, if you capture the CO2, I think it's around 21 million kilos of CO2 equivalents. So we are talking over really, really, really big volume. Saying that, it's no problem to digest or to AD waste without doing that much about it. Okay, it generates a lot of residues in the digesters, but basically you can take out the energy content. More concerning is that if you take the digestate, normally I guess it's more or less equal to the volume you put in. So you will have, in this case then, this calculation, 740,000 tons of digestate, and you don't have the space for that, I believe, in Singapore. So you have to look upon it a different way. And that is my point of view, that you have to look on the value chains and see that you have a smooth move along from the waste holder throughout until you have the final products that actually has been turned into a commodity. That is my point of view, because we are not talking about some sort of my backyard composting unit. This is industry size, large industry size. Yeah.
Thank you, Ola. I think that this is what makes Singapore maybe very interesting, because you have huge volumes in small areas. So like issues regarding to logistics and things like that is different than in others. Because Roy, when we were talking together, you were also pointing out exactly the same, that you mentioned the case you have in Japan, but also that there are opportunities in Singapore just because that this is huge volume in a small area. Can you elaborate a little bit on that?
Yeah, we've had several meetings initiated, as said, by Innovation Norway, but we have had meetings with Hysia, that is a big seafood processor in and Barramundi Group, that have already some kind of collaboration, and several government institutions has participated. And the background is, as you say, Sigridur, that Singapore is a very modern country, and they have a small, what shall I say, geographical area, which is of course ideal for Yukashima. Tokyo is a quite big area, and they are able to collect all this fish waste and bring it to a central processing unit. And it's not the highest quality of fish meal and oil, but it is valuable fish meal and oil that are used for production of other animals. And they have a zero waste policy, as you have. And it's working very nice. But as me and you discussed, Sigridur, it demands, it cannot be like Hysia alone or Barramundi alone. It demands close collaboration. I think it's a very good thing to have private initiatives like Hysia or Barramundi taking the lead, but then you need to have the government working along with regulations. And for example, it's of high importance to keep the cooling chain. The products coming out as meal or oil will never be better than the quality of the raw material that you put into the process. So there has to be some kind of legislation saying that fish waste should be kept cool. It should be picked up at certain specific hours or brought to specific pickup areas every day, and then collected, keeping the cooling chain until it comes to the central fish meal and oil plant. But if you are able to do that, I think Singapore is in a unique position to achieve it. And I remember from this meeting that you have in total around 25,000 tons of fish waste. And we can use every part of the fish. I read the story about the fish farmer or something like that, producing gray mullet. And he produced 6,000 tons of gray mullet, 3,000 tons it was, and 1,800 of those 3,000 tons were not used in the end product, was not eaten by humans. It was, some of it was going to this soup project, but it's 60% of the fish that is not utilized, and it's highly rich in, it is good food for both humans and animals. If it was, we were able to have big volumes and process it immediately, we can make human grade food from it. And we can use the bones, the heads, the blood, the cut trimmings, everything part of the fish can be part of this process. So I think it's an interesting possibility to look further into. And so does, of course, I think the participants that we have been discussing with, both from government and industry and Innovation Norway.
It's interesting. And Kai-Ning, for me, your business or your industry, the insect industry, is quite new. And I think when we were talking, because you are not like in the insect industry as such, but you are valorizing the side stream or the waste from that industry. And I think that is very, very interesting, because you are aiming at very high and valuable products. And I was just wondering, you know, what have been like the main challenges for a young startup, you know, doing this? You are really like trying out something new and changing the industry.
Yeah. For all young startups, we all face the same challenges, right? Financial, feeling our way around. Our team all comes from relevant backgrounds such as sciences and communications. But the thing is, the special thing about the insect industry is that it's so new. So all these new startups are not improving an existing model. We are really just beating our way through uncharted territory. And with Insectta even more so, because like you mentioned earlier, rightfully so, we are not an insect farming company like most insect companies are. what we do is we take the byproducts from insect farming and valorize that into higher value products. And what that does is, number one, gives insect farms a new source of revenue, thus allowing them to grow the industry. And number two, increasing the value of the insect farming industry as a whole, because now we're not just limited to agriculture. We are seeing the products that Insectta makes in things like antimicrobial sprays and masks that fight COVID-19, as well as cancer treatments and bioelectronic circuits. So I think the main challenge that comes with being in such a new industry, one is definitely legislative, because we don't want to do anything under the table. We want to make sure all our stuff is rightfully licensed. And this is even more important, especially since our stuff is going in pharmaceuticals and medicines, right? That mark of safety, security, and quality is even more important. But since the industry is so new, we have yet to set a lot of guidelines for anything insect related. Yes, you want to say something?
No, I do just please. I just have some addition after you have finished your.
Yeah. So, with the legislations being so non-existent at the moment, I think it's a bit hard for young startups to kind of have a framework to know what direction they should go. For example, Insectta wanted to go into insects as human food, but when we realized that the legislation for that was so undrafted, we thought it would be better to wait for that industry, that section to develop a bit more before we dip our toes into it. So I think legislation, finances definitely is a big challenge in the insect industry.
I think this is very interesting because when we are talking about the circular economy, often we are focusing on the existing value chains and how we can make them circular. But in your case, you are working you are establishing like a new industry, a new value chain, and that is the different challenges you are meeting than the more traditional ones. It both can be positive, but also negative in that sense, that it can be very hard to change also something that is very well established.
I think what we're doing is twofold. Well, number one, the insect farming industry is going to grow. There's no doubt about that. We are certain that this industry is going to be worth billions in just a couple of years. But one of the stumbling blocks, the insect industry farming, is the value that you can derive from it. It is very expensive to create a brand new industry, such as the insect industry. And if the only products we can get out of it are going to be like a singular kind, such as agriculture, you are stifling the value of the industry. When we open up the insect industry to pharmaceuticals, healthcare, electronics, and personal wellness, such as cosmetics, suddenly this industry becomes a lot more lucrative to go into. This increases investor confidence, increases the players in the field, and helps the industry grow. So I do think the work that Insectta is doing is not just, we're not just focusing on our little value chain over there. We're helping the entire industry, whether it's mealworms, crickets, black soldier flies, to grow.
Very interesting.
Perhaps I can just add to that. Yeah, I do think that this is a very new and very new area to go into. I did manage to catch the end of the previous presentation by Lindum, and I think it did share over there that the use of insects, the use of feeding of mixed food waste to insects, for example, is still very much a work in progress. And it's to what the output of the insects are. Yeah, and I do want to also agree with the other panelists that there is a lot of potential to better and more sustainably manage our food waste. And yes, I think these are all areas where private sector innovation would definitely play a role. I do also want to add, though, that there's one very special thing about Singapore that was not mentioned earlier, and it's that we are tropical and hot and humid. So that is also another very, very, very special issue that I think we do need to consider. Given the hot and humid environment, food waste decomposes quickly, and a very critical imperative of our waste management system is public health. We don't want a situation where waste is left maybe over the course of transportation or storage, where over the course of that process, food waste then starts decomposing and attracting vermin, attracting vectors, which can then create potential public health problems. So I mean, these are all issues that we need to balance.
Ola, you have been asking for the word.
Yeah. No, it's to Kai-Ning. I mean, personally, I fancy that we look into new applications for or new business line for food waste as a resource. But I return again to the nature of the waste that Christopher also mentioned. You are in a tropical environment. I could add that waste, you never know what's actually are put into the waste bin. That is very demanding because, for instance, if you go from food waste to food or food waste to fodder or whatever it is, you must control that the input is not contaminated with foreign objects or even polluted. So my idea or my opinion is that, okay, you can in solder fly, black solder fly, or in other, where you can control the business line all the way, then it's maybe the one way to go. And we have seen that early on in the Nordic countries also, that we try to tap out special parts of the food waste that comes in.
Same here. Yes, we only take certain streams of food waste, not all.
Exactly, and today we also tap out, let's say, bread, and can go into the pig industry as fodder, etc. But again, if you can't make it profitable, it won't. I don't think that you can survive in the long run, and therefore I'm more and I really fancy everyone that are exploring the opportunities that lies in the dig estate. Because when you have turned it and removed, I mean, all kinds of aliens that enter into when you collect food waste, and you have made it into a commodity, as I mentioned earlier on, a substrate, as we call it. And if you can extract that again into different business lines, that could be very interesting, because you have to deal with the dig estate one way or the other. I guess that you can put it into incineration, but I mean, that is also a cost, and you probably have to dewater it, or otherwise you will just chill down the ovens, or in the best case. But in my opinion, the bottleneck of today's waste to energy in this context is to deal with the dig estate. You must find, and remember that when you take dig estate out of the digester, it's in a wet form, and then you have the store. Yeah, so it's quite complicated. But as I said again, just 1 minute, Sigridur, that I strongly believe that if you put attention to this, you will find new ways to move forward with dig estate, because there you find the solution for the future, I guess.
We have a very short time. I will. It's both Christopher and Roy. You have asked for the word. I just wanted to ask you to comment a little bit on cooperation, because when we are going into the circular, and they maybe mention how you do enhance or cooperate with partners in the value chain or in the value circle, how important that is. If you can include that into your comment, for example, Roy, and Ole, if you also mention that later on. And Christopher, just you raised your hand, I think.
Yeah, Sigridur, if you don't mind, perhaps I can just comment on both the issue of collaboration as well as respond to some of what was mentioned. I do think that there is, as Ula said earlier, there is a lot of food waste in Singapore, and there are enough homogeneous streams and mixed streams to go around, I'm sure, at least for now, as Singapore starts out on on our food waste journey. I mean, we have a lot of guidebooks to try to tell people how they can segregate and treat their food waste. I mean, and there is a lot of potential just for homogeneous waste streams, right? Just a couple of quite homogeneous waste streams in Singapore are barley spent grains, okara, which is the residue left over after making soya bean tofu. So those are just some of the larger homogeneous food waste streams, and actually those are already homogeneous. And I would say, why should we should try to extract as much value out of those and turn it into food or feed, rather than to try to upcycle them instead of recycle them. And so you see, given that there are so many different food streams in Singapore, I mean, not just okara or barley spent grains, which I talked about, but also other streams such as mixed vegetable waste, or even bean sprout farms in Singapore. Right? I mean, there's a lot of bean sprouts to be taken care of. So you see, these are all areas that I think different private sector partners can come together, try to find opportunities, because in a way, I would like to say that our government is wonderful, but at the same time, I do also recognize that there are limits to knowledge. There are limits to knowledge of what knowledge that government can have, and the incentives in the private sector are very powerful, and they can try to drive partnerships between different companies in the private sector, both food waste generators as well as companies, all the companies here, in fact, Ulah's, Roy's, and Kai-Ning's companies, which can then find ways to treat those food waste and extract as much value as they can from it.
Thank you. Very short from you, all about cooperation. I think we are almost over time.
I can do that very brief. We have been dealing with food waste in the Nordic Scandinavian countries I was involved in 1996 in Oslo, when Oslo implemented the source separation of food waste. In front of us, within the EU, it will be mandatory source separation of food waste from 2023. You are following in 2024. Of course, that alone calls for collaboration. And I absolutely seen from our company, of course, we should collaborate to find the best way to treat this kind of waste, because it's basically it's the most difficult waste to deal with.
Right.
Yes, I'll try to keep it short. Just a comment on the temperatures, of course. That's why we need a close collaboration between the private industry and the governments, because there needs to be strict legislations regulating how, for example, seafood waste is treated with cooling chains, and perhaps some of it cannot be used, that we need to look at the larger players. But it's working. We're looking at projects in Vietnam. We are having it running in Japan. So it is possible through collaboration. Another example, we are talking about the remaining residues from biogas production. In Norway, we actually have a plant in a region called Rogaland, just south of where I'm sitting now, where they collect the municipal wastewater from 13 bigger areas into one place, and from into biogas, and the residues are used to produce fertilizer mixed with fish feces and fish feeds. And then they add different minerals and so on to make a complete product, and it's exported to Vietnam, used as a fertilizer. So you can, through collaboration between different industries and government, you can make valuable products also from the residues from biogas, but of course you need to lift it a bit up to become a potent fertilizer. So I believe there is a lot of potentials. I believe the black soldier fly could be a huge potential for the other type of food waste besides seafood. It produces very high larvae rich in proteins and fatty acids that can be used for animal feed. So it's a huge potential that is also now appearing as an industry in Norway. Just talked with one industry player this morning, actually, asking us. So there's a lot of opportunities, but it needs a close collaboration between suppliers, competence partners, research institutions, governments, and private industry.
Completely agree.
Yeah. Okay, I think we need to close the session. Thank you very much. It was very interesting, and I think we were so engaged that we would have continued the discussions if we had more time.
Absolutely.
And I really encourage you to continue the discussions afterwards and try to find out how to solve the challenge and how to cooperate on it. I will now present Mr. One of my colleagues who is going to close SNIC. He is a special advisor in Innovation Norway, and throughout his professional career, he has held various roles in management, design, operation, and sales in the technology and healthcare industry. His primary focus is currently on health tech, smart cities, and circular economy. The floor is yours. Thank you.
Thank you, Sigridur. Yeah, very interesting and engaging kind of panel sessions that we have. And I'm glad that we definitely can continue for further discussion with NEA, local companies, and also Norway companies to see where we can collaborate together, right? We have heard from the speakers and the panelists that the adoption of the circular economy approach will require measures to take across the entire value chain, from production and consumption to waste and resource management. At the earlier slot, we have Colorado, who mentioned that Singapore is the first country in Asia to implement DRS. Now I'd like to bring you back to the 60s. I'm a Singaporean who was born in the 60s, and with regards to deposit return scheme and food waste valorization, I would say that these are actually enforced in those days. I don't know whether you are surprised about that. So if you look at the picture, do you see these bottles in the pictures, and do they look familiar to you? I mean, mostly to the Singaporeans. How many of you actually remember that F&N, Green Spot, Yo's, Mirinda, or even Magnolia? This comes in glass bottles in those days. And we can actually return the glass bottle for 5 cents refund. And the producer will collect, will wash and reuse the glass bottles. And today, being actually shared, and research is being done, and it's actually suggesting 15 cents. And actually, Kel actually say in Norway, it has doubled to 2 kroner, which is about 32 cents in Singapore dollars. And that should really encourage many to do returns. But then after the glass bottles was away, plastic bottles replaced, and because it's cheaper and more manageable, that was where washing and reusing of these bottles stops and create a huge plastic waste problem. I'm happy today to hear that we are now finally restarting DRS after 60 years by collecting back the bottles. Prof. Sriram and Christopher Tan has actually shared NEA target to implement DRS by 2022 as first phase of extended producer responsibility framework for packaging waste management. Thanks to Prof. Sriram and also from the Plastic Recycling Association of Singapore, and also Ling at Zero Waste SG, Thomas for Alliance to End Plastic Waste. We have helped to bring together organizations, communities, institutes, government agency and funding to support plastic waste recycling as identified in the Singapore Zero Waste Master Plan. Chua has also shared with us valuable knowledge from Norway, many years of experience in the plate recycling and scheme of aluminium, PET, bottles and cans. And being from Tomra actually have made DRS possible with the reverse vending machines and the sorting and the recycling solutions. Next slide, please. So what about this next picture? Some of you who was born in the 60s in Singapore must have remembered that in those days we have many pig farms in the early years. Back then, food waste valorization is already in place. I remember each household staying in the public housing were given a bin with a cover. We'll dispose the leftover food into a bin, and they will be collected daily from this to be used as a pig sale. At the end of the year, we were rewarded with a tray of eggs. But I don't think back then there are much control in the food waste to be saved for pig use. So we used to feed the food waste to pigs. Now, interestingly, we have Insectta who are actually helping us to feed the food waste to the insect, the black soldier fly. Thank you, Kai. Or even feeding the food waste to magic factory, like what Kel has actually from Lindum has interesting share, how magic factory were able to turn waste to resource. It's just like the resurrection of the rotten tomatoes to fresh tomatoes, and even future plans for how we can actually survive in Mars. Then we have Christopher from NES sharing our Singapore Zero Waste Master Plan on e-waste, packaging waste, food waste, and recycle right. As he has shared, definitely Singapore being densely populated and having many huge food centers and malls, that does have an advantage in food waste collection. And Olav from Norsk Biogas, Roy from Fjell has shared other strategies from food waste management. So this year has definitely been a very active year for circular economy in Singapore. And definitely we are seeing real action plans being carried out and regulation being implemented to support various initiatives. In closing, I'd like to thank the organization team from MBAS, Norway Embassy, and Innovation Norway, our SNIC 2021 partners and sponsors, all the speakers and panelists for their support, and definitely all of you, the audience who are participating online. Although we have come to the end of the 2 years SNIC program, 2 days SNIC program, but we have much work to do in achieving our goals in circular economy. We need to bring our action together faster. I wish all the best and trust we will meet again in this journey to create a sustainable and scalable circular economy. Remember, waste is not a problem, but a resource. Let's turn waste to value. Thank you for your participation, and that ends our webinar today. For any follow-up, you can always contact us at Innovation Norway, MBAS, or Norway Embassy. Thank you and goodbye.
Yep.
you.